Hi everyone, my name is Sugan Anakimohan from the KM4B. Today we will be presenting about case study topic 6, which will be mainly focusing about QC tools that used in Cooper Tire and Rubber Company.
My name is Awais Hakimi Muhammad Kurmaswan.
My name is Muhammad Hakimi Muhammad Zaidi.
My name is Muhammad Zainuddin Muhammad Zainal.
First, we will be seeing about the industry's background and issue. The industry name is Cooper Tire and Rubber Company. Cooper Tire is a global company that produces tire for passenger car, light trucks and medium trucks. It headquartered in Finland, Ohio and operates many facilities worldwide. The number of facilities is 64 facilities. The company focuses on improving its supply chain and reducing costs by using high quality raw material such as natural rubber, synthetic rubber and steel. At the same time, Cooper ensures consistency, quality by employing specialists at each location to maintain corporate standards. Okay, for the second, we will be discussing about the tools that used in the industry. So the first quality tool identified in the industry is control chart. The article explicitly mentioned that Infinity QS control chart illustrate process control limit and create automatic alarm when a process exceeds its limit. Next thing is to establish more efficient production process by first understanding and benchmarking their baseline capabilities. This shows that control charts are used to monitor production process and detect variation. Instituting process control across production line help ensure that each Cooper tire is produced to the highest quality standard. By monitoring the process in real time, the company shifted from a reactive firefighting mode to in a proactive data-driven culture. The third is justification of the appropriateness of the tool. The control chart is very suitable for Cooper tire because tire manufacturing requires higher precision. By analyzing dimension data on the bed line, the company achieved over $400,000 in annual saving at one plant. Control chart help operators identify normal variation and detect unusual problem in production process. They also support ISO 9001 requirement by ensuring proper process monitoring and corrective action. In addition, the control chart allow early detection of the issue, so problem can be fixed before detect happens. Overall, they support a data-driven approach, helping the company move from reactive problem solving to proactive quality improvement. Next is data collection and application of the analysis. The data, the dimension of the data such as thickness, width, alignment of rubber layer is collected from a process like bedline, execution and cutting using real-time SPC software. This data is then used in control chart to set upper and lower control limit and monitor process stability. When the data stays within the limit, the process is stable. If it goes outside of the limit, automatic alarm are triggered to notify engineers. This actually helps identify variation, reduce defect and improve product quality. As a result, the company can focus on problem areas, improving performance and reducing cost by minimizing waste and preventing defect product. Next, we will be seeing about the consequences of not applying the tools in the industry. Without control chart, the production process cannot be properly monitored, which can lead to unstable operation and inconsistent product quality. Defects are often detected only after the production, resulting in higher costs due to the waste material, extra labor and machine downtime. The quality become reactive, solving problem only after they happen, which reduces efficiency and make it harder to find the root causes. Poor quality product may reach customers and leading to complaints, return and damage to the company reputation. In addition, it becomes difficult to maintain the consistent quality and achieve standard like ISO 9001, which can reduce competitiveness in the global market.
So, for the second tools in the QC tools is check sheets. First, I will discuss the primary quality tool used in our study, which is the check sheet. At Cooper Tire, check sheets serve as a vital manual or digital precursor to their Infinity QS SPC software, forming the solid foundation of company's data-driven culture based on the findings. These sheets are essential to effectively monitor processes and maintain adequate records. Specifically, they allow for the initial logging or critical dimensional data such as the thickness, width or length of components during extrusion and bed line processes. Next, the use of this tool is justified by its ability to provide real-time documentation, where operators can record data instantly to prevent any information loss. Furthermore, it provides systematic organization by turning random observations into structured data for analysis. Most importantly, accurate check sheets records are the necessary foundation for building more advanced quality tools such as control charts and for performing detailed comparative analysis. In terms of data collection and application, check sheets are used to gather both variable data, such as numerical tire diameter measurement and attribute data like past file counts. This analysis allows the company to identify opportunities of process improvement rather than just fixing isolated issues. This approach results in significant financial benefits, including savings of up to $400,000 annually per plant by reducing waste. Additionally, it ensures the maintenance of quality records required for ISO 9001 certification. Finally, there are serious consequences if this tool not applied. Without check sheets, a company remains reactive, wasting valuable resources on recurring issues. Small errors can go easily unnoticed, leading to higher scrap rates and the loss of the potential $400,000 in savings. Furthermore, without these records, a company cannot maintain ISO 9001 compliance, and management will lack the data-driven insight necessary for the strategic decision making and maintaining global competitiveness.
One of the quality tools that can be used in the company is a flowchart. Flowcharts are essential for mapping the entire manufacturing sequence from start to finish. According to the article, mapping current processes is the vital first step to establishing more efficient production and benchmarking basic capabilities. By utilizing these tools, quality personnel can move from a reactive to a proactive approach, using visualization to identify where improvements are needed and conducting a comparative analysis across any part of the production process. The flowchart is the appropriate tool because it provides a universal visual language for global teams, ensuring standardization. It manages complexity by breaking down multi-stage processes such as the inner line, extrusion, and cutting to pinpoint exactly where errors occur. Furthermore, these flowcharts serve as the foundational documentation required for audited processes, ensuring the organization remains ISO 9001 compliant. When it comes to data collection, during this phase, we collect the sequence of operation and critical process parameters like time, temperature, and pressure. By identifying specific input and output points for material measurements, we use flowcharts to visualize and improve the workflow. This process eliminates redundancies and hidden waste, supports SPC alerts, and contributes to an estimated $400,000 in annual savings while maintaining primary records for certification. There are consequences to not applying the flowchart. Neglecting the flowchart leads to inconsistent global decisions and a significant lack of process transparency. It forces the team into a reactive cycle, making it much harder to identify the root causes of delays or defects. This results in inadequate records that jeopardize ISO 9001 compliance, increases production costs through off-specification products, and leaves new quality staff struggling to perform a clear, documented guidance.
Lastly, I will explain the last QC tools is Pareto chart. Pareto charts is histogram ranking categories from hardness to low frequency with a cumulative percentage line. Based on the 18-20 rules, 80% of problems come from 20% of causes. Artist hints: shift resources away from process with specification toward areas that can enhance overall operation. Move away from a reactive approach, dedicating resource to putting out fires. This statement implies Pareto chart help identify the vital few problem with the biggest impact. Next is the justification of the appropriateness of the tools. Provide visual justification for management decision across 67 global facilities. Identify major causes of defect and rank them by significance, allowing focus on areas with large financial impact. Help priorities belt line defect, contributing to 400,000 annual saving per plant. Essential for global operation with multiple stage like extrusion and cutting, where not very minor issue. Next is data collection and application of the result analysis. Collect defect data, dimension variation, surface crack, air bubbles, mastic movement, and frequency of occurrence. Second is arrange data in descending order and display in a Pareto chart. Focus improvement on the vital view defect to reduce waste, improve quality, and increase productivity. Another part is support continuous improvement and cost saving initiative. Next is the consequences of not applying the tools. Difficulty in defining critical quality issue. Time and resource waste on minor problem while major defect persist. Lead to higher cost, more defect, low quality, and inefficient operation. Reduce competitiveness, customer satisfaction, and overall company performance. The conclusion is the implementation of quality control tools at Chopper Tire Rubber Company transform manufacturing from a reactive environment into a proactive data-driving culture. Control chart enable real-time monitoring, helping engineering distinguish common and special cause variation, improve tire safety, and save $400,000 annually per plant by reducing waste and off-spec components. Flowchart and check sheets provide a standard framework for managing complex global operation, breaking down process to identify inefficient and ensuring systematic data record necessary of ISO 9001 certification. PatriotChart priorities the vital view defect causing the large financial impact, allowing management to focus resource strategically. Without this integrated QC tools, the company will face unstable process, higher production costs, and a loss of competitiveness, due to inconsistency, quality, and a lack of data-driving insights.